Our notes today are going to be same lesson, 1-7. Finally, last time we're going to talk about it. And what we're going to cover is adding and subtracting. After we get our notes done. In scientific notation. Hurry up. And today's date is 10/23. Okay, so what we're going to be working on here is a different way of looking at the problem. In the other two that we did with multiplying and dividing, we would do our math, and then we'd look at our answer, and we would adjust it if we needed to. These we adjust first in order to do the math. That's kind of the weird turnabout. Plus, we have to know positives and negatives, and how to deal with adding and subtracting those. Okay? So I want to give you kind of a background on how this works. So I'm going to give you a problem, and you tell me if we can solve it. Can I add 3 dozen, let's say, eggs, and 6 eggs? Okay, what would I get?
38 eggs.
Okay, wait a second. I see the number 3 and I see the number 6. How do you get 38 out of 3 and 6? Okay, I still don't see how you get 30 from 3 and 6. Okay, Kenzie. Okay, and I don't see how you're getting that from these numbers when it says plus. Okay, Andrew.
42.
Okay, I don't see how you get 48 from 3 and 6. Bria.
Well, you said dozen, and then each dozen there's 12.
Okay.
So you would have like 12 plus 12 plus 12, then plus 6.
Okay, so here's the deal. And all of you were instinctively doing this, is you were all saying, well, I can't add dozens and eggs, so I'm going to convert in my head either the dozens to eggs, or you could even convert the eggs to what part of a dozen. So right the way this problem is written, at this juncture, it's impossible to do any math with because the labels don't match. No math because labels don't match. Now, we did have a couple of errors. Bree said, okay, what we realize is that a dozen means 12 eggs. And if I have 3 dozen, I have 3 sets of 12 eggs for a total of 36 eggs. Now, I can add that with 6 eggs, and how many eggs do I have altogether? There's your 42 eggs. How would I change 6 eggs to the label of dozen? Okay, so I could say I had 3 dozen eggs plus half a dozen eggs, which would give me 3½ dozen. So the only way to do the math is to match the labels. So what's kind of strange is that when we're doing our problems with adding and subtracting in scientific notation, we need to have matching labels. And when we're doing math, we have to have matching labels. Our matching labels deal, in our case, in scientific notation, with the bases. Okay? So let's write that down. In scientific notation, the exponent on the base 10 plays the role of place value. Okay. If the exponents don't match, you must adjust one value so that its exponent, I know we got a lot of writing today. I couldn't come up with a pithy way of doing this, matches the other exponent. So that's our big job, is to figure out how to get the exponents to match, okay? So what I want to do is kind of go back and cover something I noticed was happening yesterday when you guys were working on that problem that had multiplication and division at the same time. A lot of you were trying to figure out how to rename or adjust your answer without rewriting out that one piece that wasn't written in scientific notation. It's like you didn't want to do that extra step. So we're going to kind of investigate something and come up with what we can write down. So I'm going to write two different, oh, were we done? I'm sorry. So what I want to do is see if we could try to figure out a rule that will help us know that when I adjust my answer, am I having a positive one or am I having a negative one on my exponent without having to rewrite the whole thing out. So let's do two examples. This is still on your notes. We're going to do everything all in notes. So if it ends up taking 2 pages, it takes 2 pages, okay? All right. So both of these are not in compliance with scientific notation. What's wrong with the first one? Yeah, we see a decimal first. So this means the number is less than 1. So we've got a value that's less than 1. What's the problem on the other side?
It's greater than.
Yeah, he's greater than... Not 1. That's okay. He's greater than 10. That's the big problem on this one. So both of them require an adjustment. So let's see here. This one, I move what direction? Right. And what kind of number did I have to begin with?
7.
No. Large or small is what we're looking for. Small. So what kind of exponent do we get? Okay. Now that's just that component. When I bring in the other piece, I get for my final answer 8.7 times 10. Negative 1 plus 5 is 4. Okay? So let's look at the other one. What direction do I need to move the decimal point? I'm going to move it left. So that's going to give me 2.91 times 10 to the... Let's see. Is that going to be a positive 1 or a negative 1? Positive. So a positive 1. Hold on. You guys are going way too far. We only do one piece at a time. We're just adjusting the component that we need to adjust. We're not adjusting the 10 cubed. We're going to wait and then put the answer all together. So now when I put that all together, I get 2.91 times 10, and 1 plus 3 is 4. Okay. So now what I want you to do is to look from what our original problem looked like to what our final answer looked like. Okay? So when our original number was small, oops, which means less than 1, what happened to the exponent from the original problem to the final answer? What happened to the 5 when it became a 4? Antonio? Yeah. So it went down by how much? Yeah. So the exponent, exponent decreased by 1. Okay. The other thing I want you to look at, what direction did I move the decimal point when my number originally was small? I'm going to say decimal moved right. Okay. All right, let's go and look at the other one. I'll change color. And if the original number is large, so for us that's going to be greater than 10, so looking from here to the final, what happened to the exponent? How would you describe going from 10 cubed to 10 to the 4th? What happened? It increased by how much, Jordan? From 3 to 4? It increased by 1. So the exponent increased by 1. So again, what direction did we move the decimal point when our number was originally large? So what direction do we move here, the decimal point, from the 29.1 to make it 2.91? The decimal moved left. So this is what we can take from this. Actually, I'm going to hold off. All right, so I'm going to move over. So let's summarize. So our chart here, to summarize, it's going to be movement of decimal and we had two movements. We either moved the decimal point to the right or we moved the decimal point to the left. But the key thing we want to put in, it was what was the effect on the exponent. Okay, so this is when we look back at that list of information we just did. So I'm going to flip back there for a second. So for example, here, we moved the decimal right. What did I do to the exponent when I moved my decimal right? What? It says decrease by 1. So let's go back to our chart. And we're going to write, when I moved to the right, my exponent decreased by 1. Okay? And then when I moved my decimal to the left, what happened to my exponent? It increased by 1. Okay? Now, as we are going through this next piece, we're going to relate back to this conclusion chart. Okay? So, directions are going to ask us to evaluate. So if you guys want to go on to the new page, that's fine. I'm going to just continue here. Ooh, that should say EX. Evaluate, which means find an answer. Answer must be in scientific notation. Now, I'm just going to throw this out at you. Make sure you understand this. If you decide to write everything in standard form, add or subtract, and then take the answer and put it into scientific notation, you will not get very much points because you're missing what we're trying to teach you is how to add or subtract in scientific notation, okay? So just know that. Remember we talked about backup plans, but this backup plan is going to cost you 1.5 out of 2 points. So you don't really want to use this backup plan. Answer must be in scientific notation. So as we go through each step, I'm going to kind of write what we did in that step. So first problem. The quantity 6.89 times 10 to the 4th. And I want to add to that the quantity 9.24 times 10 to the 5th. So you look at your exponents and ask, are they the same? No, I've got an exponent of 4 and I have an exponent of 5. This is kind of like having dozens and eggs. Okay? Right now I cannot add 3 dozens with 6 eggs and get 9 dozen eggs. Okay, that doesn't make sense. So I have to come up with a game plan. Here comes the part that is freedom. We have the ability with our chart above us to take either one of these and change it. We can either increase the exponent on the first one to 5, or we could decrease the exponent on the second one to 4. We pick. It doesn't matter which way we do it, we will get the same answer. So, which one do you want to do? You want to change the 4 to 5 or the 5 to 4?
5 to 4.
I heard 5 to 4 first. So that's the one we're going to do. So let's take this guy, and we're going to want to decrease him. So let's look at what it says. To decrease by 1, I move the decimal. Look what it says. Right. Okay? So, first thing I'm going to do is to decrease this exponent by 1. I need to move the decimal point to the right. So first thing we're going to do is adjust one of the values so the exponents match. And it doesn't matter. You can choose which one you want to do this with. So this guy didn't change at all. He's still 6.89 times 10 to the 4th. This guy, however, did change. He now becomes 92.4 times 10 to the 5th. Or, sorry, to the 4th. Actually, I'm going to make him purple. Now, there's actually distributive property going on. Cameron, Wheeler, we're taking notes. Sit up. So what we can do is both of these say times 10 to the 4th. So what I want to do is just pull out the decimal parts. And this is to remind myself that my answer will end with 10 to the 4th. Okay? Unless I need to adjust my answer. So next thing we're going to do is do the math with the coefficients, or with the decimals. Now, what do we have to remember to do when we add or subtract decimals? What's the important bit? Yeah, we have to make sure the decimals line up. That is the crucial piece. So I'm going to take my two numbers, and it doesn't matter who goes on top and who goes on the bottom. All that matters is that the decimals are lined up underneath each other. I tend to put the bigger guy on top, just it's my habit, because when it comes to subtraction, I have to do it that way. So I'm going to put 92.4 on top, lining up decimal points, 6.89. Notice that there is a gap. What can I put in that gap?
0.
Yeah, and it's very important that you get in that habit, because if you don't do that with subtraction, you get the wrong answer. Okay. You don't need to, because it's whole numbers. You can if you want to. If that makes you feel better, you can do that. So then we start, in this case, adding. Decimal stays where the decimal is. So 0 plus 9 is 9. 4 plus 8 is 12. We carry a 1. We have 3 plus 6 is 9. And then we have 99.29. And then we have the times 10 to the 4th. So we have to verify the answer is in scientific notation. Okay. Is it? No. It's not. So we need to adjust it. Remember, it's 99. But let's use our chart. I'm going to move my decimal point what direction? Yeah, I'm going to have to move it left once. According to my chart, what do I do to the exponent when I move left?
Subtract.
Okay, look here. When I move left, it says to do what? Add 1, okay? So I'm going to add 1 here. So my answer, final answer, is 9.929 times 10 to the 5th. Okay, so let me just ponder this for a moment. We took the larger label changed it to a smaller label, and we ended up having to adjust our answer. I wonder if we chose the smaller label to go up to the larger label, would we have the same problem?
No.
So in our next example, let's try that, okay, and see if we start with the smaller label to make it the larger label, what do we have? All right, so let's do the next example. Everybody good on this one?
Wait, no.
If you need to, go for it. Yes, no? Oh, okay. Let's do the next example. So this time we're going to choose the smaller exponent to become the larger exponent, see if that makes a difference. So this one I'm going to give you a subtraction. So let's see, we have the quantity 7.83 times 10 to the 8th minus 11,610,000. Oh, wow, this problem looks a little different. So what do you think I'm going to do on this one?
Subtract.
Okay, hold on. We got an issue. What's the issue? Marcy?
Do we put that one in scientific notation?
Yeah. How can we do math and scientific notation if they're not both in scientific notation? So in the event they give us a standard form and a scientific notation, we first need to rewrite the problem into scientific notation. So rewrite value into scientific notation. So 1, 2, 3, 4, 5, 6, bam, 7. So this value now is 1.161 times 10 to the 7th power. And then we still have the rest. That's 7.83 times 10 to the 8th. Okay, so last time we did large down to small, and we had to readjust the answer. So let's try smaller exponent to the larger one. Okay, so I'm going to go back to show you the chart again. I want to increase the exponent by 1. So what direction does it say I'm going to move my exponent or my decimal? It says left. Okay, so let's try this. So this says move the decimal left, and that will increase by 1. Okay, so this guy now is 0.1161 times 10 to the 8th. And then we still have, this guy has just been like taking a nap like Cameron over there.
No, that camera.
That one. So what we did here is we adjusted value to make exponents match. Okay. All right, so now that they both have times 10 to the 8th, this is when I can pull out just the decimal parts. So I have 7.83, take away 0.1161, and then outside is their common 10 to the 8th. All right, so let's do math. So larger number goes on top. Smaller number on the bottom. Fill up gaps with zeros. And subtract. So I can put my decimal point. It just comes straight down. Ooh, I have to rename, but there's nothing next door. So I have to go all the way to the 3, take 1 away from him. That makes this guy a 10. But then I take 1 away from him, making him a 9. So I can make the last guy a 10. So now I have 10 take away 1 is 9. 9 take away 6 is 3. 2 take away 1 is 1. 8 take away 1 is 7. And then I have a 7. And then I add the times 10 to the 8th. Oh. So when I took the smaller and went to the larger, I didn't have to adjust my answer. But when I took the larger exponent and made it smaller, I had to adjust my answer. All right, we're going to try one more and see if there is an actual pattern here. Okay, you guys ready? All right, we got uno más. We're all good. Life is good. Life is like a box of chocolates. So we have 593,000 take away 7.89 times 10 to the 6. So, job 1? Yeah, we're going to take that first number and put it into scientific notation. So I get 5.93 times 10 to the 5th. Because it moved 5 places. All right, so which was the one that did not require adjustments? Big to small or small to big? Okay, so let's do small to big again. So what am I going to do to add 1 to this exponent? So I'm going to go back to that chart. What direction would I go if I want to add 1? It says move to the left. So move to the left 1, and that gives me 0.593 times 10 to the 6th. And then, again, this guy's been waiting around. 7.89 times 10 to the 6th. Because they both have the 10 to the 6th, now it's just 0.593 minus 7.89, and then we have the times 10 to the 6 on the outside. Okay, so I'm going to do subtraction. And subtraction, the signs, how I set up the problem, the signs don't matter. What matters is whoever's larger has to go on top, because that's how we do subtraction. So 7.89 would go on top. 0.593 would go on the bottom. But what do I know about the 7.89? What? Well, that's true. What else do I know about him?
You have to fill in a 0.
We did that. What else is true? Look at your problem, Sean. The sign. There is a negative attached to this guy. So what does that tell you your answer is going to be?
Negative.
Yeah, we have more negative. So I always place my sign in immediately so I don't forget about it. Okay. The negative comes from right here. Whatever's in front, whatever sign's in front of a number is attached to that number. Okay? And I can rewrite any subtraction problem to an addition problem. Okay, now I'm going to technically subtract because the signs are different, and that's what the rules of integers say. So we're going to go ahead and subtract. Again, we have issue here. We're going to have to rename. So I get 10 take away 3 is 7. I can't do this, so I'm going to rename. 18 take away 9 is 9. 7 take away 5 is 2. There's my decimal, and then we get this. And then I bring down this. I think we're on to something. So it appears to me the best strategy is to take the smaller exponent and adjust it up by moving the decimal left. So that would be my suggestion. We can still get the same answer the other direction, but it may require us to do another piece of work with the answer. Now, my last question I want to ask is, what if one exponent was 5 and the other exponent was 7? What would I need to adjust by to go from 5 to 7? 2. Would that change our chart? No. If I'm adding 2, I'm still moving left, but I'm moving left twice. Okay? All right, so your homework's on the board. Good luck.